Okay, so haven't done a video in a while, been busy with school, but now I'm going to incorporate the video with stuff that I'm learning in school. Namely, I want to prove 5.5 and 5.6 in the book Thermophysics, which is this one. You can't see it. Right here, Concepts of Thermophysics, 2nd edition. So that's the book I'm working out of. If you'd like to get caught up with this, this is chapter 5. So first thing I'm going to do is show that 5.5 and 5.6, the equations, work. Okay? So let's begin with 5.5. And here's some standard integrals that'll be helpful. These three I'll be using. And then if you're not caught up, it's important to know that g v of x is proportional to our Boltzmann, our Maxwell-Boltzmann distribution, or Boltzmann factor, I should say. Okay, so the first one, what do we have? We have the integral from negative infinity to infinity of vx, g of vx, dvx is equal to 0, and we have to show that to be true. Well, let's see what we have. We have the integral from negative infinity to infinity of v sub x, and g v of x we know is proportional to our Boltzmann constant, which to get rid of the inequality, this is something that we worked out earlier, is m over 2 pi the Boltzmann constant times the temperature, square root e to the minus mvx squared over 2 kBT. So that's this whole part. That's this. So we can put that in. And I'll factor out the constants. So m over 2 pi kBT square root. That's out there. But we still have the e to the minus mvx squared over 2 kBT. dvx is equal to 0. Now, the way that we know this is equal to 0, actually, we're not using any of those integrals. We're going to have to use the property of odd functions. So this is odd. This is v of x. You could think of it as just being like x. And e to the negative x squared, you can think of it as being similar to that. Obviously, there's constants, and it's going to change the look of the graph. But e to the negative x, odd times even, is an odd function. And what that means is if we were to break this integral up, as such, from, let's say, negative infinity to 0, do it like this, plus the integral from 0 to infinity that's going to all be equal to 0, because this is going to be the opposite of this. They're going to cancel out, given the properties of the odd function. You know, if we had, let's just use the example of a line. And let's just say it goes from 2 to 2. This area is going to be equal and opposite that area. So just in general, the integral of negative a to a of an odd function is equal to 0. So that's all there is to that one, is just using our even and odd properties to make this integral. What would be pretty difficult, actually not too bad.